So I picked up this off eBay recently. It's a little power meter that goes up to 2.4 gigahertz, and I've tested it. It actually goes up to 2.49 gigahertz, and then it goes a little bit wacky. But it only cost me £21, and you know, it's quite an accurate little measuring tool as a power meter. It doesn't go beyond 0 dBm. It works fine in the minor scale. But it does have a little built-in attenuator, so you can measure, you know, slightly higher than 0 dBm, but you have to factor in the attenuator and then remove it again for your final measurement. But it's not too bad at measuring. I've tested it at a few different power levels, and it seems to be pretty okay. 2 or 3 decimal places. I mean, you've got to factor in a little bit for the loss of the cable, but for £21 it's not too bad at all. So what I'll do, I'll show you a couple of measurements so it'll give you an idea of how accurate this is. Have a quick look at the interface, then I'll show you the circuit board and everything else. But something else that I want to do, I want to put this into a enclosure, because as a quick reference tool, you know, here in the lab, I think it'll be pretty useful. It's a shame it doesn't go beyond the 2.4 gigahertz, but for £21 you can't really grumble. So I've hooked everything up. I've hooked up the power. I'm just going to run this off a 9-volt battery. This will run from you know, 7 volts to 12 volts, so a 9-volt battery runs this fine. I've just hooked up some coax here with an SMA connector on the end. And again, I think I would have preferred some solder pads, so I'll remove this when I put something a little bit more permanent on there, rather than screwing it down into this connector here. But this is the LCD screen, and it just fits back over the top here on that header board. So let's have a look at this then. I'll you know, put some different power levels into it and show you the attenuator, so you can judge for yourself how well this works. So as you can see, I'm feeding in -5 dBm, and recorded on the screen there on the power meter we're getting -4.4, 4.5. It's fluctuating around a little bit, but I think a lot of that's down to the connection for the coax on the board itself, because depending on where I position my thumb when holding this, if I position my thumb a little bit closer to that connector there, it does make it go a little bit wacky. But you know, if you factor in the loss of the cable itself, then a measurement of 4.4 dBm is not too bad at all, and especially for £21 you can't really grumble at that. So this is a reading using the internal attenuator, and this is a weakness that I've found with this particular power meter, is the internal attenuator is not that good. It's using a resistor and capacitor network to do the attenuation, and at the moment I've got it set to 4 dB attenuation, but that's much closer to 2 dB attenuation. It's measuring that 2 dBm signal coming out of the signal generator here, and it's displaying it as 1.7, 1.9 fluctuating there dBm, but the attenuator is so far out of whack you can't really trust the internal attenuator. So this time then, instead of using the internal onboard attenuator, I'm using a physical attenuator here. I've got it in line with the coax. It's a 3 dB attenuator, and you know, it's not too bad at all. I'm feeding in 2 dBm power, and if you factor the attenuator back in again, it's showing on the screen there 0.78 dBm. I mean, if you factor the attenuator back in, you're not getting too far off the mark of what actual power is being delivered. So this is the main board of the power meter then, and there's not a great deal to it. There are some resistors and capacitors on the underside, but that's to do with the attenuator, the internal attenuator, that doesn't work all that well. But basically RF power meters, there's 2 different designs that are out there, and one is a thermistor design that measures the slight temperature variations in different power levels. And the second one is a diode, and I believe this over here is the diode, but again it's surface mount, and I can't really get any information off that. And this chip here is the LCD driver chip. We know that because most of the tracers are going off to the LCD screen, and this chip here is doing all the measurements. So it's taking the you know, the signal from that diode there, and doing the calculations to display the power level. But these two chips in particular, they've done a really good job of grinding these down, so we can't get any serial numbers off there. They've done it to quite an excess actually, but I can't tell you what chips they are because it's impossible to identify them. And there's a close-up of them. You can really see the gouges on the surface of those two chips there. They really didn't want you finding out what kind of chips they are, especially the smaller one, which is the one that's probably doing all the work. And on the back of the board you've just got the resistor and capacitor network here that's doing the attenuation, or trying to do the attenuation. You've got your RF signal coming in here and your RF ground here, and that's all there is on the back. There's not much else at all. So what I'm going to do then is mount all this in a little project box. I'm going to get rid of this connection here, and I'm going to solder on permanently a little SMA bulkhead connector. I'm going to run this all off a 9-volt battery. I'm not going to bother with a external power supply, putting in a little DC jack there. It's not really worth it. And we'll test it again with this in place, because I did find when I was putting my thumb in this area here, it was making it you know, a little bit jittery, and it'd jump around a little bit. So possibly if we make this modification with the SMA connector inside a project box to you know, put it all together and kind of protect it a little bit from the outside world, it might perform a little bit better than what it did. Now, as for the project box, I thought this one would fit the purpose quite nicely. It's got this slope here where I'm going to mount the LCD display. On here I can have the different buttons here for the function buttons and the attenuation, although I'm probably not going to use the attenuation on this because it is quite poor. And we can have the SMA connector coming out at the side here, and you know, fit everything inside with this little 9-volt battery. And you know, the bottom base will screw on and off, so we can take that off, change the battery when it runs down. I'm not sure how long a 9-volt battery will last, but it'll probably last quite you know, a decent amount of time, because there's not a lot on here to power with the LCD screen, so I can't see it needing batteries quite frequently. I'm pretty sure I could run it up for quite some time off a 9-volt battery, and you know, I think it'll look quite nice inside this little project box. So before I start cutting into the project box in my Dremel, it's a good idea to lay out the parts on the inside of the project box, just to make sure there's enough room to make sure that what you've got planned in your head will actually transfer onto the project here. But already I see here that the base is catching on those little standoffs, but I will be removing those anyway. I don't need them. And also, when I cut the rectangle out to make room for the LCD in the project box as well, that'll stick up about 2 or 3 millimeters as well anyway. But the main thing here is to make sure that I've got enough room at the side here for the on-off switch, just to make sure there's enough clearance. But even if I did make a mistake, I could easily mount the on-off switch down here. Just make the little spades here shorter, because I'll be soldering directly onto those anyway, so I could probably make it fit in this small space here. And also on this side, there's not a lot of room here between the power meter board and the outside wall, and I do want to mount my SMA bulkhead connector here. But I think if I solder my coax to the underside here and then loop it around so there's not a lot of strain on that coax, there should be enough room there. It shouldn't be a problem. Now, my students at school quite often ask me how I get my ideas and you know, I can look at something and come up with a different approach than they probably will. And to be honest, it's not something you can really teach. It's experience of doing different things. And when I was a kid, I couldn't afford, you know, expensive tools and specialist tools, so I kind of made do with what I had, and I still do that today. If I've got a project, I think about the skills and tools that I've got, and you know, how I can achieve that project. So sometimes I'll buy something that's already made if it's going to be easier to modify that so I can achieve a better outcome. And I've just looked at this project box, and at this project box here, we've already got some things that can help us, because we've got two straight edges here and here that are you know, milled into the project box, if you like, part of the shape. And this is a perfect straight line here. So I want to put the LCD screen 10mm in from this side, and that way I should be able to fit everything in. So what I've got here is my ruler, and I can butt it up against that groove there, and I know it's perfectly straight, so I can measure in 10mm at the side there. Now, something else that comes along with experience is this LCD screen is extremely popular with hobbyists. You can buy this particular LCD screen at lots of different places online, and this is one that I've saved from a previous project. I saved the metal housing here that goes around there, the bezel, if you will. And the reason I save this is because I can use it as a guide just to draw around when I want to cut out you know, an opening in a project box to fit something like this. So it's a nice little thing to have. You can also very carefully take apart the bezel off this LCD screen and then put it back again when you've finished, if you want to. But what I can do now is I've marked in my 10mm that I need from this side here, and using this other straight edge at the top of the project box is butt that up against that straight edge, and then I know that this is all straight now. Line it up with that mark that I've put in there, and now I can just draw around this bezel, and I'll have the perfect rectangular shape to cut out for my LCD screen without having to do any complicated measurements or anything like that. So now that I've drawn around it for the shape, what I'm going to do now is just go over it again with a ruler, just to get the corners nice and straight at a right angle, so I can follow it a lot easier with my Dremel cutting wheel. Now, all that's holding this in place at the moment is little corners of metal in each corner here. Now, to cut those out, I'm just going to use a very sharp utility knife and kind of bring that down, applying pressure and a rocking motion, and that way you can cut the corners quite cleanly. If you try to do that with a cutting wheel, you'll have saw marks coming out here and here, and it'll just look messy, so you probably have to think about sanding it down then and painting this enclosure. But with a sharp utility knife, it's really soft metal aluminium this, and you can cut through it quite easily, especially when it's only a small corner. So once we've got this cut out with the Dremel tool, it's best if you now switch over to a hand tool, and probably 10-15 minutes of work with this, and we'll get a much better finish than trying to grind the rest of this off with a Dremel tool, for instance. And the secret to filing something like this flat and level is the way you use your file. If you used it in that kind of position there on that small surface area of the file, you probably wouldn't get it so flat. But if you use as much of the surface area as you can on the file and hold it at this kind of angle, doing it in that kind of motion, you will end up getting this quite flat, a lot flatter than you would if you just attacked it in that you know, that kind of angle. So if you keep it at this angle, as much surface area as possible, with the file, you'll get a much better job. So a little bit of patience and a little bit of filing, and it fits in there quite nicely, and it's in there quite tight, but not tight enough that it's jammed in there. And you know, I don't have to glue it, it should be in there fine as it is, but you're always best if you can try and avoid not use glue with something like this. It just makes it easier to do any repairs in the future. So next I'm going to cut out the rectangle for this little rocker switch here. Now, one of the mistakes a lot of people do when cutting out this for a project box, especially, you know, if it's a piece of work you're doing at school or college, is you want to make sure that you get at least one straight line, because there's nothing worse than looking at something like this and it being a little bit, you know, off. And it only has to be a fraction of a millimetre off and your eye will just catch it, especially when you've got this nice and straight. If it's just off a little bit, looks a little bit wonky, it doesn't quite look right. But here on this project box, we've got this straight edge here, and we can butt our ruler up against that like so, and we can use that to measure off at least one straight line down this side here. So I'm just going to put a little mark there like so. So now I'm going to turn my ruler around and again get it flat on that groove there, and this time I'm going to use it as a sort of set square to line it up with that mark. And I know this edge here is nice and straight, exactly 5mm away from the edge here, and I can just draw a line all the way down there, and then all the rest of the measurements I can do from that line, because at least I know that that line is perfectly straight. So if you take a look at these rocker switches, they have this overhang here, and it's about a millimetre all the way around there, and that can hide quite a few sins, especially when it comes to cutting this out. But from edge to edge there, it's 15mm, so I'm going to draw a line that's 13mm to create this rectangle, and then I can make it a little bit bigger if I need to with the file. It just makes sure that I don't go beyond that overhang there. And now I can use the same method again to come in with the ruler on this side, get it nice and flat in that groove there, and draw a straight line down to the bottom using the edge of the ruler. And for the final mark, the length of the rocker switch is 20mm, but we've got this overhang here as well, so we're going to measure off at 18mm. So I'll just take my ruler, get it lined up at 18mm there, put a little mark just there, and we're going to draw a line along that way, and then we'll cut out this rectangle for the switch. Now there's a little trick you can do to help you cut out something that's a little bit smaller. Here's one of the cutting discs for the Dremel, but if you take a look at it, it's a lot wider than what I'm going to be cutting out here, so you could probably get away with it there, but you're definitely trying to cut that way, it's way too big. So what I tend to do is collect small ones like this and save them, and these are perfect for when you're cutting out something a little bit smaller like this. So, you know, if you get a cutting wheel and you've worn it down to that size, don't throw it away, save it, because it's really good for cutting out small sections like this here. So now we've got the power switch fitted, I'm going to drill out 3 holes here for these push to make switches. Basically when you push them down, they complete a function just like a tactile switch. So I'm going to use these to replace the tactile switches on the PCB board here. Although, as I say, the attenuator doesn't work all that well, but I figure that if it's there, I might as well put these switches on the front here. Now one thing that is quite difficult to do by hand is to drill 3 holes like this and keep them in a nice straight line. So what I've done to help me is I've made this little template. I just made it in Publisher printed it off and cut it out and stuck it on here, and that way I can center punch the holes here, here and here, and then I can drill them and get them as straight as I possibly can by hand. I mean, the only other way you're going to get them perfectly straight is if you made a metal template jig as a guide and use that to direct your drill into the correct position. So this is the next best thing. It will be a lot straighter than trying to eye it up anyway, because you never get it straight if you try to do that. So the modification is almost done now, so all that's left to do is to solder in all the wires for the on-off switch and the battery terminal here, and extend these little tactile switches out so these push to make switches will override these ones. And I've also desoldered the connector there for the RF input, and I've got a SMA bulkhead connector. I've already drilled it and connected it to the outside of the project box here, and I'm just going to solder the coax directly onto these two terminals. It may make a lot better connection than having the connector there and turning those you know, those screws down there. A lot better connection soldering it in place. This would probably benefit you know, in the future if the designer of this decides to put a SMA PCB connector on there. It'll just be a lot more professional than these little screw down connectors here. So I've got everything wired up now and ready to connect it all together, and I just wanted to show you these little surface mount tactile switches. All you have to do is solder a wire at each end on those little solder pads on these tactile switches, and then basically solder these two onto the push to make switches, and it overrides this switch then, so you can control it by the front there. And you can also double check that you've got a good connection if you put your multimeter into continuity mode and then press the tactile switch. Then it should make the circuit and buzz. So I'm going to solder all these in place, and you may also note how long I've left the wires. That makes it easier to connect and disconnect this if I need to in the future. And also make sure that your power you know, wires are extremely long as well, because you can just tuck them away in here. There's quite a lot of space. And again, same thing, you can remove this board from the LCD screen if you need to work on it in the future. So everything's wired up and back inside the box now, and I'm going to add the 9-volt battery. And just to stop this rattling around, I've got some double-sided foam tape on here, so I'll just stick it down to that back wall there and connect it up, and then I can power it on and off with this switch here. And with the 9-volt battery in place, there's not a great deal of wasted space inside this project box, but it's turned out rather well. So hopefully, fingers crossed, we've got everything wired up correctly. And it's powered on nicely there. Quick test of the push to make switches here. And they work just fine. So to test both of these power meters then, as you can see, I've got them both turned on side by side here on the bench, and I'm feeding in a -5 dBm signal into this splitter, which splits out that signal to each power meter. Now the splitter does have a 3 dBm loss attached to it, just you know, purely by splitting the signal you get a 3 dBm loss. And as you can see on the power meters here on the readout, the top one here -8, -2, fluctuating a little bit. This one is -2, -4 dBm, fluctuating a little bit. So you know, for £20 they're not too bad at all as far as their accuracy is concerned. There's a little bit more loss with the cable here that's not really showing up on these two multimeters, multimeters power meters, but you know, for £20 it's not too bad at all. And when you put them in a project box like this, you've got yourself a neat little power meter. And of course, because these two run on batteries as well, it makes it a lot more flexible. You can take it outside if you want to, and I can position it around here in the lab without having to worrying about feeding in power to operate it. So for £21 then, and free shipping from China, if you're looking, you know, for something like this, just to do a quick and dirty test on something like your FPV setup, if it's 2.4 GHz, just to test the cables and everything to make sure they all work, then I don't think you can go too far wrong with this. Yeah, it's not a piece of mega accurate scientific equipment, but you know, just to get a good idea of what's actually happening, it's well worth £20. So I hope you enjoyed this video, and if you did, please give it a thumbs up. I'll put a link in the description to the seller that I purchased these two off eBay. And as I say, hopefully you enjoyed the video, and hopefully you'll join me on the next one.